Today we're going to be talking about polygons and their exterior angles. Our goal is that we will be able to classify polygons and find exterior angle measures, and we will be able to find the number of sides of a regular polygon given the measures of the exterior angles of the polygon. So what is a polygon? Here's some shapes, and some of them are polygons and some of them are not. So a polygon is an enclosed figure with all straight edges. So no curves, and it has to be closed, meaning each edge connects to another. So this first one, this is a polygon. This one, because of this curved edge, is not a polygon. This one that kind of looks like some spiky hair or fire, that one is a polygon, all straight edges. Again, yes, it's a polygon. You know it as a triangle. And this one is not a polygon because of this side here where it is not enclosed. Now there's two types of polygons. There are convex polygons and concave polygons. Convex polygons has all corners on the outside of the figure. A concave polygon caves in. In other words, the corners, or some of the corners, are inside the figure. Like here's a corner that's inside, and these corners are inside. Now let's learn the names of some polygons. A polygon with 3 sides, you should already know, is a triangle. A polygon with 4 sides is a quadrilateral. If it has 5 sides, it's a pentagon. 6 sides is a hexagon. A 7-sided figure is a heptagon. An 8-sided figure is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11 sides is an undecagon. And 12 sides is a dodecagon. Now what if it has n sides, or any number of sides? We sometimes just refer to it as an n-gon. It's just a generic way of classifying whatever number of sides. Something like a polygon with 14 sides would be known as a 14gon. So if it gets any higher than 12, you just put the number in front of gon. The sum of the exterior angles for any polygon, so all of these, any that you can think of, is always 360 degrees. Now there's some special polygons. There's equilateral polygons where all the sides are congruent. There's equiangular polygons where all the angles are congruent. And then there's regular polygons where all sides and all angles are congruent. So all the sides are the same, and all the angles are the same. So let's say we have a regular polygon. What is the sum of the exterior angles? Well, we just said the sum of the exterior angles for every single polygon is 360 degrees, always. Well, what would be the measure of one exterior angle? We know we have 360 total, divided by the fact that a heptagon is 7 sides. So we're going to divide it by 7. So if we take our calculator and we do 360 divided by 7, we get this big long decimal. So we're just going to say 51.429 degrees. We're going to estimate. We're going to round to 3 decimal places. So what if we have this figure here? We want to solve for x. So these are all our exterior angles. They're on the outside of our polygon. We know the sum of them has to be 360, and sum means add. So we're going to add these all together. And I find that when we have this many sides, to make a list like this, to add them all up, is a lot easier than writing them left to right. So you have 2 plus 3, which is 5, plus 3 more is 8, plus 2 more is 10, plus 4 more is 14, plus 1 more, we have 15 x's. 60 plus 2 is 62, minus 5 is 57, plus 3 is 60, plus 10 is 70, minus 10 is 60, and we know that that equals 360 degrees. So now we're going to solve. Subtract 60 on both sides. 15x equals 300. Divide both sides by 15. And we get that x is equal to 20. What if we know that a regular polygon has an exterior angle of 42 degrees? How many sides does it have? Well, we said if we wanted one angle, we had to do 360 degrees divided by the number of sides, which we typically represent with n. That equals 24 degrees here. So we multiply both sides by n. We would get 360 equals 24n, and then we end up dividing by 24. So a shortcut would be 360 divided by the angle. Regardless, n is equal to 15 sides. Go ahead and fill in your summary, and I'll see you in class.